Mars. The very name evokes a sense of wonder. A celestial neighbor draped in red dust, it has beckoned to humanity for centuries. Our fascination with Mars is deeply rooted. It stems from its accessibility in the night sky, a fiery point of light that shifts and changes with the seasons. It comes from the tales spun by science fiction, stories of daring adventurers and strange alien landscapes. But our fascination is also fueled by something deeper. Mars represents the unknown. It holds the possibility of answering one of humanity's most fundamental questions. Are we alone in the universe? Today, in 2025, our understanding of Mars is more nuanced than ever before. We see it not just as a distant red dot, but as a complex world shaped by a rich and dynamic history. Join me now as we delve into the latest discoveries from the Martian frontier. The journey to Mars is a journey of discovery. For decades, scientists have wondered, was Mars always a dry, desolate world, or did it once resemble a young Earth, teeming with oceans and rivers? This evidence is not just a single clue, but a symphony of geological whispers. A chorus of ancient riverbeds carved into the Martian landscape speak of a time when water flowed freely. Vast deltas etched into the planet's surface tell of ancient lakes and seas. And hidden within the rocks themselves, we find minerals that could only have formed in the presence of liquid water. One of the most intriguing pieces of evidence comes from the Perseverance rover tirelessly exploring the Jezero crater. This crater was once a lake fed by a sprawling river delta. Perseverance is finding evidence of this watery past, including intriguing rock formations that could have only formed in the presence of flowing water. The rover is also uncovering signs of past hydrothermal activity, suggesting that Mars was once a warm and geologically active world. Liquid water is essential for life as we know it. The fact that Mars once had abundant liquid water raises the tantalizing possibility that life may have arisen there, just as it did on Earth. The search for life on Mars is perhaps the most compelling reason we explore. The search for life on Mars is not a search for little green men, but for something far more subtle. Biosignatures. These are chemical or physical traces that could indicate the presence of past or present life. The Perseverance rover is equipped with a suite of sophisticated instruments designed to detect these elusive clues. It's searching for organic molecules, the building blocks of life. It's analyzing the chemical composition of rocks and soil, looking for telltale signs of biological processes. And it's even collecting rock and soil samples, carefully storing them for a future mission that will bring them back to Earth for detailed analysis. The search for life is a meticulous and challenging endeavor. Proving that a particular molecule or rock formation was created by biological processes is incredibly difficult, but the rewards of such a discovery would be immeasurable. Imagine the moment when scientists announce to the world that they have found definitive proof of past life on Mars. It would be a watershed moment in human history, fundamentally changing our understanding of life in the universe. Even if we don't find definitive proof of past life, the search itself is incredibly valuable. Section 4. Mars beneath the surface, unveiling the planet's heart. While rovers like Perseverance explore the Martian surface, another mission has been listening to the planet's heartbeat. The InSight lander, which touched down on Mars in 2018, is equipped with a seismometer, a sensitive instrument that can detect even the faintest tremors within the planet. These tremors, known as Marsquakes, provide valuable clues about the interior structure of Mars. By studying how seismic waves travel through the planet, scientists can learn about the different layers that make up Mars, from its crust to its mantle and core. InSight's observations have revealed a planet that is far from geologically dead. Marsquakes, though generally smaller than earthquakes, occur regularly, indicating that the planet's interior is still active. Understanding the interior of Mars is crucial for piecing together the planet's history and evolution. Section 5. A thin veil unraveling the mystery of Mars' atmosphere. Mars today is a cold, dry desert world, its surface constantly bombarded by radiation from the sun, but it wasn't always this way. Evidence suggests that Mars once had a much thicker atmosphere, one that could have supported a warmer, wetter environment. So what happened? Where did Mars' atmosphere go? Scientists believe that the answer lies in the solar wind, a stream of charged particles constantly flowing from the sun. Unlike Earth, which has a strong magnetic field that deflects most of the solar wind, Mars' magnetic field is weak. Over billions of years, the solar wind has gradually stripped away Mars' atmosphere, scattering it into space. To better understand this process, NASA is preparing to launch the ESCAPADE mission. ESCAPADE will study Mars' upper atmosphere and its interaction with the solar wind. Understanding how Mars lost its atmosphere is not just an academic exercise. Section 6. Bringing Mars to Earth. The ambitious sample return mission. Imagine holding a piece of Mars in your hand, examining it under a microscope, analyzing its chemical composition with the most sophisticated instruments on Earth. This is the tantalizing promise of the Mars Sample Return Mission, one of the most ambitious and complex space missions ever conceived. The Perseverance rover is already hard at work collecting rock and soil samples, carefully storing them in sealed tubes on the Martian surface. The next phase of the mission involves sending another spacecraft to Mars to retrieve these samples and bring them back to Earth. This is no easy feat. It involves landing a spacecraft on Mars with pinpoint accuracy, retrieving the samples, launching them from the Martian surface, and safely returning them to Earth. Bringing Martian samples back to Earth would allow scientists to study them in unprecedented detail, using instruments and techniques that are simply not possible to send to Mars. The Mars Sample Return Mission is a testament to human ingenuity and our insatiable thirst for knowledge. Section 7. Destination Mars. A future awaits. The journey to Mars is more than just a scientific endeavor. It's a testament to the human spirit of exploration, our innate desire to push beyond the boundaries of the known and to explore the vast cosmic ocean that surrounds us. The discoveries made by missions like Perseverance, InSight, and ESCAPADE are not just adding to our understanding of Mars, they're inspiring future generations of scientists, engineers, and explorers. They're fueling the dream of one day sending humans to Mars. Landing humans on Mars is a monumental challenge, one that will require international collaboration, technological innovation, and unwavering dedication. But the rewards of such an endeavor would be immeasurable. Imagine the first human footprints on Martian soil. The journey to Mars is a journey that will challenge us, inspire us, and ultimately lead us to a deeper understanding of ourselves and our place in the cosmos.